Okay, going to do a little review video on Mars. Did another video on Venus. The unit test will be over Venus and Mars. So let's go ahead and jump straight into this one. The red planet, our neighbor, not our closest neighbor, but our neighbor nonetheless. Mars has some interesting orbital properties. It has a very, very eccentric orbit, 0.09, which is quite dramatic compared to Earth's, which is 0.02. What that really means is that Mars is much closer in the perihelion than it is when it's aphelion, which of course is always the way it's going to be with a elliptical orbit. But the difference is quite dramatic, 1.67 over 1.38. This affects Mars' climate, and we'll talk more about that when we get there. Has an orbital period of 1.88 Earth years, so it takes almost 2 years to get there. 2 years to orbit. Receives only about 45% of the light that Earth does, and that's because it's further away. And the further away you go from the light source, the dimmer it appears, right? So, it appears red in the sky, but it's really not red. It's really more of an orangish. It's really more of a orangey rust color. We'll get back to why it's a orangey rust color later. Not near as reflective as Venus. Venus got those high albedo clouds. Mars doesn't. So, a very little atmosphere to reflect off of. It's a long ways from the sun, and this kind of brownish color is considered on the lower end of the albedo spectrum. It's about 0.53 Earth radii. You don't really need to know that number specifically. You see, it's about half the size of Earth. It's a pretty small planet. Has two moons, Phobos and Deimos, and these are captured asteroids. We'll look at those a little bit later. It's got a mass about the 10th of Earth, which makes its overall density way low, which is about the same as the moon. Again, you don't need to know these numbers. You just need to know that it has low mass and a low density. This basically tells us that for the size of the planet and the density that it is, that it has a relatively small core, very similar to the moon, and it's cooled off probably. Rotates in about almost an irregular Earth day, 24.6 Earth hours, and it's tilted relative to the ecliptic at 24 degrees, whereas Earth is tilted at 23.5. So this leads many people to say that Mars is a lot more similar than Venus to Earth. And it is in many ways. Looking at Mars from a long ways away, it looks like a red dot in the sky. It's actually pretty strikingly red. Its most distinguishable features are the polar ice caps. If you look at it through a telescope, they are very noticeable with a telescope. Some other things that we noted before we even got there, right? It has a very dusty surface, right? It's kind of a dirty, deserty kind of thing, and it's susceptible to hurricane-like windstorms. Now, this picture over here to the right shows solar panels with a bunch of dust on it, and that's just kind of to illustrate how dirty it is. Dusty. Hate to say dirty. It's a beautiful picture of the planet itself and a couple of its key features, including the Tharsis region and the Valles Marineris. We took Global Surveyor. The Mars Global Surveyor was a probe that the U.S. launched and took topographical data of Mars. It also took visual photographs. It's ridiculously accurate photographic data as well. But the topographical data really revealed a lot of new things to scientists, in particular the northern hemisphere being a lot lower in elevation than the southern hemisphere. You can see that here too with the elevation scale on the right. Northern hemisphere a lot lower. You should also notice in this picture that the southern half seems to be much more heavily cratered. That leads us to believe that the northern hemisphere has been resurfaced with magma. So this is exactly what I was just telling you. There's just a couple of pictures. Northern hemisphere looks very smooth, and like it's, it even looks like it has some flow over it. And the southern hemisphere is kind of pot marked and older looking, and looks like it's been there a while. Talk about some major features of Mars. The Tharsis Bulge is a large region about the size of North America, including Canada and Mexico. There's a large area, and that's this region over here that's in the red, all the way up to here. This is the bulge, and it's called the bulge because it sticks out of the planet almost. The video we watched says it calls it the pot belly of the planet. Sticks out quite a good bit. Olympus Mons is located here. It's the highest mountain in the solar system. Another key feature in the southern hemisphere is the Hellas Basin. The Hellas Basin is a ridiculously large impact crater. Right, the crater itself is just about the size of the United States, not quite as wide as the entire country, but it is a very, very, very large impact crater. Hit the planet some time ago, probably around 4 billion years ago. We're talking about volcanism on Mars. Only type of volcanoes, or at least what we believe anyway, that are on Mars are shield volcanoes. And these are much like the ones on Venus, right? They form over hot spots. They're like the volcanoes we have here that form the Pacific Island with the Hawaiian island chain or the Midway island chain. We talked about those in the Earth unit. So the point is, we do not see evidence of plate tectonics because these shield volcanoes are just in the same spot. We don't see chains of volcanic islands or what would look like volcanic mountain chains on Mars. We don't see that because we don't believe there's any tectonic movement. The largest of the volcanoes, again, is Olympus Mons. It's about 700 kilometers in diameter. It's a little bit smaller than Texas, pretty large volcano, obviously. Texas is a large state. Rises 25 kilometers in the sky, right? Everest, by comparison, rises about 9 kilometers. So it's quite a large, not only is it wide, but it's really tall. So big because surface gravity is low, and any magma coming out of that with a low surface gravity would have cooled. Well, the lava itself would not have flowed as quickly, and it would have cooled at a quicker rate. And if it continued to do that, it would just kind of pile on top of each other, and that's essentially what it did. Mars has some interesting impact cratering. The craters themselves tend to look like what is otherwise known as slurry, kind of muddy ejecta. Not your typical straight lines that you often see in places like the moon or Mercury. You can see this kind of slurriness, and that has a lot to do with Mars's makeup. We believe that liquid, it looks like liquid splashes up, and the belief is that the permafrost that is within the dirt, right, with H2O ice, is melted when these comets or asteroids come in and hit, because the energy just is so hot, obviously, that it's melting the rock itself. So it's definitely melting the ice, and the ice just kind of, as it turns into water, just kind of gets swooshed all over. I don't know if that's a word, swooshed, but anyway, they make for interesting impact craters. Not all of them are like that, I'll say that, but a bunch of them are. Another key feature on Mars' surface is the Valles Marinaris, and it's called the Mariner Valley. It's named after the Mariner spacecraft that first identified it in the 70s. Believed to be caused by the Tharsis region upheaval. Now, this is a bizarre theory, but we just don't geologically understand how it could have formed. It does not look like water erosion, like in a canyon on our planet. So, if you look at its proximity to the Tharsis region, here's the valley itself, the Tharsis region is here. The general theory is that this whole region upheaved all of a sudden randomly, and for some unknown geologic reason. And as this upheaved, it basically ripped this part of the planet. It's very large, about a fifth of the size of Mars, and it's about the length of the United States. Mars also has evidences for erosion, which again points to the fact that Mars has water or has had water in some degree. So we're going to look at some of the structures here that look like they show signs of erosion. So this is what we're looking at here, right? It looks like water has kind of trickled down and made some kind of tributaries. So this is in the inside of a crater. I like how they kind of blew that up, but it's just such a nice picture. That's from the Global Surveyor. Well, we believe that water was on the planet in large quantities, especially in the northern hemisphere, probably an ocean kind of thing, right? How deep, who knows? But it's definitely a interesting idea. We also believe that there are possibly like river-looking things that are now kind of dried up, and we call these runoff channels. So, was it a river flowing? Hard to say. It could have. It's probably more likely a area that water flowed on occasion due to something, right? For instance, like something that would be like a flood or something like that. But it probably was a fairly regular pattern. Outflow channels, by contrast, seem to be almost like isolated events. They're not, something that's happened again and again and again, but something that caused a large amount of water to kind of whoosh all over the planet during one period, one or more periods, but not anything consistent. So this would be a difference here, right? Here's a runoff channel, so this is probably something that had water flowing in it several times. And when I say several, I mean, who knows? The numbers could be 1,000, could be 1,000,000, could be 10. But it's structured in a way that looks like it had water going on a fairly regular basis. This is a runoff channel or a river bed on Earth as comparison, just to kind of give you an idea of what it looks like. So that's some mature stream stuff that I talked about in class. Outflow channels. These are the things that are kind of just like more short-term events, right? So this kind of shows that it seems like water was released from somewhere over in this region, and it kind of flowed down here, and it kind of went around some of these higher structures, and seems again to be more isolated. Same thing with this. Water was probably released from somewhere down here, hits the lip of this crater, goes around it, and on both sides, and it kind of forms this tear-shaped structure because these are the lower areas of topography. This looks like a Martian river delta, so looks very similar to the Mississippi River Delta. It shows deposition of sediment, where it looks like it's carried from one place to another like a river. Hard to say if it's a constant flow or if it was just more of an outflow channel looking thing. These little bands here kind of lead to the idea that Mars possibly had an ocean to it, because we see these things on our planet where the ocean kind of laps up on the surface, and these form what we call tidal rhythmites. And tidal rhythmites are the idea that water comes up here and water goes back, and water comes up here and water goes back, and it drops off sediment each time, kind of leaving it as a record that there was large amounts of water there. And it is also in the northern hemisphere, which is another point that we believe that it was the ocean in the northern hemisphere. Mars has some polar ice caps, and these are interesting because they're two different types. The northern and southern one, southern one's really tiny. The northern one is really large. But they both have what we call seasonal caps. And the seasonal cap is CO2 ice, or dry ice. We notice in the summer, the one in the southern hemisphere essentially disappears. It evaporates in the atmosphere, and this has to do with that orbit again, how close it gets during its summer. And when it's in the winter, far away from the sun again, it refreezes and reforms in those polar regions. Underneath the seasonal cap in the trying to think, the northern hemisphere polar ice cap is what we call a residual cap. And residual means like it resides or it stays there, right, and it's permanently frozen. And this is underneath the seasonal cap. And we believe that this residual cap is H2O ice. This is kind of visual clue to the seasons, right? This is like summer, and then this would be winter, right? And the cap is noticeably larger. Space probes on Mars. First lander we had there was the Viking. We spoke about this before. Performed chemical tests, showed that it had an iron-rich content that was oxidizing, and this is what accounts for this rusty color. The Viking was a successful geological experiment, but it was not. Did not find anything biological that it was hoping to. These are some shots. That's a shot from the Viking, and this also is a shot from the Viking. So the color is a little bit more distorted because the photograph is not as good back in the 70s, obviously. This is a photograph in the early 2000s. This is from the Spirit or Opportunity. Spirit or Opportunity, I'm not sure which, but that just shows you how much better of an image it is. So, Spirit and Opportunity are the two rovers launched in 2003. I'm going to kind of just fly through some of these pictures. I provide a lot of pictures to kind of show you the surface according to a much better camera. This is the geologic tool called the RAT that the probes used. They're twin rovers. Goal was to find evidence of liquid water. Opportunity found some things that looked like it was formed underwater. Again, never found like liquid water. So the Opportunity is still going as of 2015. The Spirit died in 2010 when it got stuck in the sand and it couldn't get free. The latest rover on the planet is the Curiosity rover. Curiosity is much bigger. So here you can see the Spirit and Opportunity. This is the Pathfinder, which is the first rover. But the Curiosity is much, much larger. Landed in 2012. It's the most advanced rover ever launched. Landed in a region called the Gale Crater, and it's an area that we believe could show evidence of water. Had a little bit different mission. It's got a lot more atmospheric and climatic wizardry on it, right? And still doing geologic sampling on Mars too. The beauty of the Curiosity is it's much larger, can carry more machinery. The wheels are much larger and much less apt to get stuck, and it's also nuclear powered. So dust on the solar panels and battery life is really not a factor. Nuclear power should go for a long time. Martian atmosphere. It does have an atmosphere. It's very thin. Book says it's 1/150th the atmospheric pressure as Earth, right? So it's very, very, very thin. It is mostly CO2. Believed to lost most of its gases due to low surface gravity. If you remember how we talked about that with Earth and how helium is, our planet doesn't have enough gravity to hold on to helium. That's why helium balloons go up. This planet is much smaller than ours and doesn't have the gravity to hold on to some of these smaller atomic mass-wise gases. So if you look at the atmosphere composition, most of it is CO2. CO2 makes up about 95% of it, and it's a heavier molecule, and gravity will be able to retain that molecule a lot easier. You see some other percentages here, and again, you don't need to know all these numbers. You take away that it's mostly CO2 atmosphere. It does have some oxygen. It does have some water vapor. Interestingly enough, although its atmosphere is almost all CO2, like Venus's, because it does not have as much pressure, which really applies to the density of the air, it doesn't have enough CO2 molecules to retain the heat like normal greenhouse gases would on our planet or on Venus. So it's still very, very, very cold, long story short. It does contain a troposphere where there is some weather. We do see what we believe are water clouds forming. They dissipate. It doesn't really rain, we don't believe. You see fog in the canyons. Now this fog is caused by dry ice as it's evaporating off, and kind of it fills in craters, and these do form other kinds of clouds, which if you see these carbon dioxide ice clouds, the same kind of thing. Martian internal structure, we don't know really. We don't have seismographs on it. We don't know like we know about the moon. Remember the moon, we have seismographs on it from the Apollo missions. The Mariner 4 detected no magnetic field. The Mars Global Surveyor, which is a much better probe and was launched 30 years after, found a weak, about 1/800th the strength of Earth's magnetic field. So it's ridiculously weak. It's a small core. It's solid. So why is it so weak? It rotates fast, right? It rotates in 24.6 Earth hours, right? That's Venus's problem. But the problem here is that it doesn't have a liquid core, and if it is present, it probably did have one. But if it was present, it's probably cooled and solidified. ALH 84001 is a piece of meteorite found in Antarctica that is believed by many to point to signs of life on Mars. The video talked about it extensively. This is the little structure here that is believed to possibly be a fossilized bacteria. So, discovered in '84, wasn't studied for some years after. Some of the carbonate globules in it contain things that they appear to be, could possibly be bacteria. So, it's a question mark. It's up for debate. It's astrobiology's biggest point of contention. Got two moons, Phobos and Deimos. They're both small. They're both ugly potato-looking things that are not very round. They are most likely captured asteroids. Did not seem to form the same time as Mars, right? If you remember back to the moon formation theories, right? This would not be the sister theory. This would be more of your capture theory idea. Phobos is the larger of the two. Deimos is slightly smaller, but they're both only a few tens of kilometers across. They're fairly small. I mean, asteroid-wise, they're pretty decent-sized asteroids, but for moons, they're really considered to be on the smaller end. Alright, folks, I know that's a little bit long, but Mars is a complex planet, so hopefully you stuck through it, and you'll be ready for the test, and I shall see you in class.